What about that? Do you still see the board, guys?
Yes po.
Okay. So again, I had a pre-recording about the discussion on the three approaches of defining the six trigonometric functions. I hope you were able to watch that because we're going to discuss today one of these approaches, and this is called the right triangle approach in defining the six trigonometric functions. So let's now begin. Right triangle approach in defining the six trigonometric functions. To recall, right triangle approach uses a right triangle in defining the six trigonometric functions. In right triangle approach, the angle is limited to an angle that is a positive acute angle, that is between 0 and 90 degrees. So meaning you cannot work on trigonometric functions that is that are, for instance, 90 degrees, 0 degree, less than 0 degree, greater than 90 degrees, and so on. So we're limited to working on trigonometric functions of an angle that is between 0 and 90 degrees only. Okay? So let's start. Consider the right triangle ABC having 90 degrees at C. So this is the illustration. Triangle ABC, 90 degrees at C. Opposite to angle A is the side denoted by op. So meaning this is the opposite side. Then we have the side AC. So this is called adjacent relative to angle A. And then we have the hypotenuse, which is the side AB. So again, in this figure, hyped means hypotenuse. Opt means opposite side to angle A. Then we have they add adjacent. So this is adjacent side to angle A. In this right triangle, there are 6 ratios of sides that we can associate. These ratios, called trigonometric ratios, are as follows. We have opposite over hypotenuse. This is relative to angle A. So we have adjacent over hypotenuse, opposite over adjacent, and the other 3, the reciprocals of these 3 respectively. Hypotenuse over opposite, hypotenuse over adjacent, adjacent over hypotenuse. So these ratios, again, are called trigonometric ratios. Okay? So, and of course, these are trigonometric functions. And they are called trigonometric ratios because we obtain them from what? From the ratios of the sides of a right triangle. Because of their importance, they are given special names, defining the 6 trigonometric functions as follows. So we have 6 trigonometric functions of positive acute angle. So let A be a positive acute angle of the right triangle ABC having 90 degrees at C, as shown in figure 1. So this is the figure that I'm going to use. Then we define the following. Sine of angle A, which is abbreviated sine A, and that is equal to opposite over hypotenuse. So this ratio, opposite over hypotenuse, is given what special name? Sine of angle A, or simply sine A. Then for the ratio adjacent over hypotenuse, the special name given is cosine of angle A, or simply cosine A or cos A. And then we have for opposite over adjacent, the special name given is tangent of angle A, which is abbreviated tan A. And then we have cotangent of angle A, abbreviated as cotangent A, and that is equal to adjacent over opposite. Notice that this is the reciprocal of the tangent of angle A, which is opposite over adjacent. And then for this reciprocal of cosine of angle A, we have hypotenuse over adjacent, and the special name given, secant of angle A, and that is equal to, when abbreviated, sec of A. No? So again, secant of angle A is hypotenuse over adjacent, while the reciprocal of sine of angle A, so sine of angle A is opposite over hypotenuse. So we have cosecant of angle A, the reciprocal of that, which is cosecant of A. So this is abbreviated CSCA, cosecant of angle A or cosecant A, and that is hypotenuse over opposite. So it is important for you to be able to become familiar with these ratios. So again, these trigonometric ratios are trigonometric functions. They are called trigonometric ratios because they are obtained from what? From the ratios of the sides of a right triangle. So take note that A here is between 0 and 90 degrees for the meantime. And the sides are all positive in values. The symbols sine, cosine, tangent, cotangent, secant, and cosecant in themselves have no meanings standing alone. To have an interpretation, each must be followed by what? Each, again, must be followed by an angle. So in other words, if you have sin, which is equal to 4 over 5, or sine, which is equal to 4 over 5, there's no angle after sine, so it's wrong. Okay? So this is the one that is correct. For instance, sine A is equal to 4 over 5. If you're going to write your function without an angle, so that is just the name of the function. It has no value. But if you want to have meaning for that function, you must what? Attach to it an angle. So again, sine A is equal to 4 over 5, and that's the correct one, sine A. So sine A is a quantity, meaning it has a value, and the value is 4 over 5 in this case. So this on the left side, so this is wrong, huh? Don't forget that. So let us have an example. Find the 6 trigonometric functions of angle A given the right triangle below. So this is the right triangle ABC, having the following sides. BC is 7 units, AC is 24 units, and the hypotenuse is unknown. Since we do not know hypotenuse, we have to find it first, because to define the 6 trigonometric functions, we should know all the sides. So we are looking for the 6 trigonometric functions of angle A. It is also possible to get the trigonometric functions of angle B. But what we are asked, trigonometric functions of A. So relative to angle A, this 7 is opposite. Okay? While 24 is adjacent to angle A, and AB hypotenuse. Okay? But if you, for instance, if you have angle, so relative to angle B, the one that is opposite is 24. and the one that is adjacent to angle B is 7. So it depends on what? On the angle that we are going to consider, whether let's say this acute angle, angle A, or angle B. So let's focus on angle A. So again, 7 is opposite relative to angle A, 24 is adjacent, hypotenuse AB. So first, let's determine the hypotenuse. Hypotenuse is equal to, by Pythagorean theorem, square root of 7 squared plus 24 squared. So that is this side over this side. I mean, this side, square it, plus this side, square it again, then take the square root for its sum. So the sum is 625. Okay? So again, 49 plus 24 times 24, that is 625. Square root is 5. I mean 25. So sine A is defined as opposite. So 7 over hypotenuse. But what is hypotenuse? 25. So sine of angle A is 7 over 25. Cosine of angle A. So that is adjacent. We define it as adjacent over hypotenuse. So we have 24 over 25. What about tangent of angle A? So that is opposite over adjacent. So we have 7 over 24. Cotangent of angle A, that is just the reciprocal of tangent A. So the reciprocal is 24 over 7. So that is adjacent over hypotenuse. Secant of angle A, that is equal to hypotenuse over adjacent. So we have 24 over 25. Hypotenuse over adjacent. Secant of A. What about cosecant A? Cosecant A is equal to 25 over 7. That is hypotenuse over opposite. So these are the 6 trigonometric functions of angle A from this right triangle. Okay? In case you have questions, you just talk. So let us have another example. Find the 6 trigonometric functions of angle B given the right triangle below. So this time, I want trigonometric functions of angle B. So relative to angle B, the one that is opposite is the side AC, while BC is the adjacent side to angle B, hypotenuse 10. So there is a missing side since we need all the 3 sides to define the 6 trigonometric functions of angle B. So we have to solve for this opposite side later. Also, we're asked to evaluate the value of this expression and also this expression. So let's have. So let's begin by computing the opposite side. So what's the opposite side? Hypotenuse. So what's the hypotenuse, guys? So hypotenuse is equal to, what's the value? So that is 10, 10 squared, then minus, no? 4 squared. So hypotenuse squared minus 1 leg squared. And this is equal to 100 minus 16. So what is 100 minus 16? That is equal to 84. Okay? 84 has a perfect square factor, no? So 84 divided by 4, that is 21. So what is square root of 4? 2. Remaining out inside the radical, 21. Okay? So the opposite side is 2 square root of 21. So let's now determine the value of sine B. So starting with sine B, that is opposite to angle B is 2 square root of 21. So this is 2 square root of 21. Is that right? Sine B, 2 square root of 21. Over what? Over hypotenuse, over 10. So simplifying, we get square root of 21 over 5. So that's the sine of angle B. What about cosine B? Cosine B is adjacent to angle B, that is 4 over hypotenuse. Simplifying, we get 2 over 5. Okay? What about tangent B? Tangent B is opposite, so that is 2 square root of 21. Is that right? 2 over square root of 21. Wait. So that is 2 square root of 21. Over what? Over, is that correct? Opposite, that over adjacent. What is adjacent? 4. Okay? So giving square root of 21 over, what's the value? By the way, who's the president of the class, guys? Who's the president of the class?
Good morning, sir. Ako po.
Okay. In case I have questions and I want to ask your classmates, you will be the one to call the name, huh? Or an option, you can answer if you want. Or you call your classmate, okay?
Okay po.
Over 2, no? Over. What about cotangent B? Cotangent B is adjacent, that is 4 over opposite. Opposite is 2 square root of 21. So remember, when you have a radical in the denominator, to be in simplest form, so you have to eliminate, or you have to get rid of that square root of 21 in the denominator. Meaning, we have to rationalize the denominator, no? So let's multiply by square root of 21. So this is square root of 21. Also, the denominator, you have to multiply by square root of 21. So this will not change the value. It will only change the form because what we multiply is equal to 1. So simplifying this cotangent, we get what? So we have, Miss President. Babae ba President?
Opo, sir.
Okay. Miss President, what is the simplified form?
Po. Sorry, sir.
What is the simplified form? Cotangent of B.
Um, um, Wait, sir. Sorry, can you please repeat the question?
What is the simplified form?
2 square root of 21 over 21.
Over 21. Okay, very good. And then for secant B, or what about secant B? You can call a name or you can answer if you want.
Secant B is
How do you define secant B?
secant B is hypotenuse over over adjacent 10
over adjacent. Or what is adjacent?
4 po.
4. Oh, that is, when simplified, 5 over,
2.
no? Okay. Oh, what about cosecant? Or you can call a name.
Lan Lance Beltran po.
Okay. Would you answer, please? Cosecant B. How do you define cosecant B?
Cosecant B is what happens when
Hypotenuse over.
it's hypotenuse over opposite, sir.
Okay, so what is hypotenuse?
The hypotenuse is 10.
Then, what about opposite?
The opposite is 2 square root of 21.
So when simplified, we have to multiply by what?
Square root of 21
So we
all
have to
over square root
multiply
of
by
21.
square root of 21. Multiplying by square root of 21 over square root of 21, both the numerator and denominator. So giving what value?
5 square root of 21 over 21.
5 square root of 21 over
21.
21. Okay. Now next, evaluate the expression sine B minus cotangent B all over cosine B. So what's the value of B? So we have to replace its function involved by its value. No? So for instance, sine B, we have already sine B square root of 21 over what? Over 5. Yan. And then, what about cotangent B? Cotangent B is 2 square root of 21 over 21. Okay? And then cosine B is 2 over 5. So that is cosine B. Now, to simplify this complex fraction, so we need to multiply both the numerator and denominator by what? By the LCD of all the fractions involved. So what is the LCD of 5, 21, and 5? So that is 5 times 21, right? So we multiply both the numerator and denominator by 5 times 21 over, so that is 5 over 5 times 21. So multiplying both the numerator and denominator by 5 times 21, we get the following. So 5 times 21 multiplied 2 is square root of 21 times 5. So 5 is cancelled, giving 21 is square root of 21. What about 5 times 21 multiplied by 21? I mean 2 is square root of 21 times over 21. So 21 is cancelled. So getting 10 is square root of 21. Is that correct, Miss President? Then over what? So 5 times 21 multiplied to 2 over 5. 5 is cancelled. So what is left in the denominator? Ms. President, what is the denominator?
21 po. Oh.
What's the denominator?
42, sir.
42. So that's equal to 42. Okay? So what is 21 minus 10? Because these two radicals are similar, so we can combine them as a single radical. By the way, if you have radicals, so can we add, for instance, square root of 3 and square root of 5, Ms. President?
No po.
Where?
Po?
Square root of 3 plus square root and the square root of 5. Can we add square root of 3 and square root of 5?
I believe not, sir.
Huh?
I believe not.
No?
Yes, sir.
We can't add square root of 3 and square root of 5?
Um, um,
Let's say you are asked, what is the sum of square root of 3 and square root of 5? Let me rephrase it. What is the sum of square root of 3 and square root of 5?
sir, I,
Square root of 3 plus square root of 5. So that's the sum. Oh, so this is the sum. So
oh,
can
sir, sorry po.
10 square root of 5.
I thought you meant like combine. Oh, never mind, sir. Thank
So
you.
we can add, but we cannot combine as a single term. But we can add. Any real number can be added. Okay? Again, any real number can be added, but there are real numbers that we cannot combine as what? As a single term. In this case, we cannot combine square root of 3 and square root of 5 as a single term. But we can add. Okay? So, this is 21 square root of 21 and 10 square root of 21 are what? Are similar terms. So, we can combine them as a single term. So 21 minus 10 is what? That is 11, right? So times square root of 21 over 42. Okay? Yan. Over 42. I think we can have it here. So that is 11 square root of 21 over 42. Can we still simplify that? Ms. President, you can call a name or you can answer.
Nathan Lim po.
Huh?
Sir, hindi na, sir.
Did the
We
answer?
can't simplify it.
Is it already in simplest form, guys?
Yes, sir.
Yeah, so we have 11 over square root of 11 square root of 21 over 42, no? So that's
Yes,
already
sir.
simplest form. So we can no longer simplify that. Okay, what about letter B? Letter B, we have cosecant of, what is letter B? Cosecant squared of B multiplied to 1 plus cosine B. When you have cosecant squared B, we mean it cosecant B quantity squared. So if I have sine squared B, what does it mean? It means sine B quantity squared. What we square is the value of sine B, not the angle B. Is that clear, guys? So again, cosecant squared B means cosecant B quantity squared. Okay? So we have, what is cosecant B? Cosecant B is, where is that? So 5 is square root of 21 over 21. So we have 5 square root of 21 over 21. And then quantity squared multiplied to 1 plus. What is cosine B? Cosine B is 2 over 5. So that is 2 over 5. So squaring this first factor, we have 5 times 5, that is 25 over what? So 25 over 21. Is that correct? What is the square of 5 square root of 21 over 21? Huh? That is 25 over 21. Is that correct, guys?
Yes,
Yes,
sir.
po.
So we have, what about the simplest form of 1 plus 2 over 5? So what is the single fraction for this sum? So that is
7
7
over 5.
over what? Over 5. Is that correct? So 25 over 5 is 5. 7 over 21 is 3. Is it 3? So we have 5 over 3 as our answer. Okay? So that is the value of such expression. Do you understand, guys? Or can you follow, guys? So far? Let's move to the second one. This is the third one. Let's say you're given the value of secant A, which is equal to 13 over 12, where angle A is between 0 and 90 degrees. So meaning, this angle is positive acute. So you expect that all the measures of the sides are positive, because later when we go to functions of any angle, it is possible for the side to be negative, meaning we're going to consider the side to be directed. But in our case, all the sides are considered positive for the meantime, because we're given the restriction that angle A is a positive acute angle. So find the other trigonometric functions of function values of A. So we're given secant A, whereas of what? Of sine A, cosine A, tangent A, what else? Cosecant A and cotangent A, na? So 5. So we have to find the remaining 5 trigonometric functions. So we define secant of A as what? Hypotenuse over adjacent. So 13 over 12 means hypotenuse over what? Over adjacent. So we can take the value of hypotenuse as 13, then adjacent as 12. But it doesn't mean that hypotenuse is exactly, it's just 13. So possible that hypotenuse is 26, but if you take hypotenuse as 26, you're going to take adjacent as 24. Okay? So arbitrarily, we take hypotenuse as 13, adjacent 12. So because the ratio, the simplest form of the ratio equivalent to secant A is 13 over 2. So the smallest integer that you can have for hypotenuse is 13, and for the adjacent 12. So we have to solve for what? For the unknown, no? So we need to know the opposite. So how do we solve for opposite? So opposite is equal to. If you do not want opposite, you can assign a letter if you want. What is the value of that? So that is 13 hypotenuse, then square it, minus 12 squared. So giving what? What's the value? Ms. President, when I call your name, you can call your classmate or you can answer if you want. What's the value? Help me guys with the value.
Hold on po. Sorry. Five. 5 po.
5. So square root of 25 and that is 5, no? Okay, thank you. So we can now define the other functions. What are the remaining functions, guys? Ms. President, you can call a name.
Cosecant, cotangent.
You can call a name.
Oh, okay, sir. Sorry.
Do not answer every time you're asked. When I call your name, you can call a name.
Chastetan, sir.
What are the remaining functions? Starting with
Sine po.
sine of what? Sine of?
Sine of A.
Sine of A or sine A, no? Or simply sine A. What is sine A?
Sine A is opposite over hypotenuse.
Opposite
So 5 over 13.
over 13. What about cosine?
Cosine A is adjacent over hypotenuse.
Adjacent, what is that?
12 over 13. Then tangent is 5 over 12. Tangent A is 5 over 12.
5 over 12. That is opposite over
over adjacent.
adjacent. The next
Then
two, remaining
cosecant
two.
A,
Cosine, I'm sorry. Cosecant of what?
cosecant A is 13 over 5.
By the way, that's pronounced not cosecant, but cosecant.
So, sorry, sir. Cosecant
So,
A.
I don't understand the tongue of Americans, why they prefer it to be cosecant. It's like in other parts of our country, no? When they pronounce some words, it's strong, no? They pronounce it is so like for instance, egg, it is egg, no? Instead of egg, egg. Okay. So same thing here. Secant, cosecant. We have cosecant. Again, what is cosecant of
Cosecant A is 13 over 5.
13 over 5, which is just the reciprocal of sine. And
Then
then for
cotangent
cotangent,
A is 12 over 5.
12 over 5, which is just the reciprocal of tangent. That's it. See, very easy. So trigo is easier than analytic geometry. Which one is easier, analytic geometry or trigo? Now, by the way, we may be fast because lecture can be, what you call this, can be watched again. You can repeat watching. That's why we can, sometimes you're fast because if we'll be slow, we will not be able to finish the topics within 6 weeks. And then because you will have quiz, remember, the quiz will not be delayed. So whether we finish or not, so what you will do is just to watch the remaining topics. So in case we will not able to finish, so in case you can't catch up, you just repeat watching the video or read the lecture, okay? So after all, this is to be shared, the video, no? So number 4, if tangent theta is equal to 0.7, where theta is a positive acute angle, evaluate the expression sine squared theta plus cotangent theta all over square root of 149 secant theta minus cosecant squared theta. So what's the value of this expression if you're given tangent theta equals 0.7? So first we have to find what we need, no? So we need sine theta, cotangent theta, and secant theta, cosecant theta. So let's start working on tangent. Tangent theta is equal to 0.7. So can you help me, guys, what to do? So we're given 0.7. So what am I going to do with the 0.7 so that I can find the other functions that I need in order to evaluate this given expression? Ms. President, call a name.
Carl Galapon po.
That could be expressed as 7 over 10, sir, or
Okay,
a
0.7.
multiple.
Okay, we have to express this as a fraction because that is how we define trigonometric ratio or function. So this is 7 over 10, no?
Yes.
Or we have it 14 over 20 and other equivalent. But the best, I think, ratio that can represent 0.7 is 7 over 10, okay? Which we define as what? As opposite over what? Over?
Adjacent po.
Over adjacent. So we can take arbitrarily the value of opposite as 7, adjacent as 10. So again, I say arbitrarily because it's not fixed to be 7, the opposite. It's not fixed to be 10, the adjacent. Because you can change the ratio as long as equivalent to 7 over 10. So but if we take opposite equals 7 and adjacent equals 10, then the hypotenuse is equal to what? Or what's the hypotenuse? Hypotenuse is equal to, what's the hypotenuse? Equal to? Huh? Wala, hindi na nagsalita ang Miss President. Miss President,
Yung service po.
a name. So when I ask you, you have to call a name. Square root of what?
Square root of 7 squared plus 10 squared po.
You don't want to call a name? You can call a name.
Sir, I feel bad when I call names po.
No, it's all right. You just call. Because the reason why I asked you to call a name, because I can't see the names. Okay? So that's why you will be representing me in calling the name because I am in full screen. Okay? It's all right calling a name. So because it will help them to understand better what we're discussing. So that in case they are sleeping, so they will become awake, no? So what is this? Square root of 149, no? So 149. Okay, so that is now the hypotenuse. So we can now define we can now evaluate this expression. So we're given what? Sine of squared of theta plus cotangent of theta and then all over square root of what? Square root of 149 secant of theta and then cosecant of, so that is cosecant squared of theta. Okay? Yan. Let me move it a little upward. So that is minus cosecant squared theta. Let's plug in values. For sine theta, we have how do you define sine theta? That is opposite, which is 7. So that is 7 over square root of what? Square root of 149, right? But we have to square it. So this is equal to minus plus what is cotangent? Cotangent is adjacent, which is 10 over cotangent over opposite, so 10 over 7, which is just the reciprocal of tangent. And then square root of 149 times what is secant theta? That is hypotenuse. Square root of 149 over adjacent, so over 10. And then finally, cosecant squared theta. What is cosecant? That is hypotenuse, square root of 149 over opposite over 7. So squaring it, so we get this, no? Let's simplify this. So this is equal to. So to simplify, we have for the first fraction in the numerator, that is 49 what? So that is 49 over 149, right? And then plus 10 over 7. All over denominator is 149 over 10. And then minus 149 over 7. So we're going to simplify this. So let's simplify. The numerator is equal to, so 49 divided by 149 plus 10 over 7. So the numerator is equal to 1,833 over what? Over 1043. So I use calculator, ha? Divided by, when I divide, I multiply by the
Sir,
of whatever the denominator is, reciprocal of the denominator. Again,
sir,
49 divided by 149 plus 10 divided by 7, I use calculator, and that is equal
Sir.
to
sir,
1,800 over 1,043. The denominator is 149 divided by 10 minus 149 divided by 7, which is could you please check if what the denominator is? So what is the denominator, guys?
Sir.
Yes, may mali ba ako? Parang may
sir, is in cosecant squared theta supposed to be
Oo.
149 over 49 po.
Oo nga. 149 over, alin ang mali ko dito? Natututo na ako.
Second po, right?
Ha?
Yung pangalawang uh,
Ay,
149.
49, sorry. Because we square this. Okay. Yan. So the denominator is 49. What is the denominator, guys? So the denominator is 149 divided by 10 minus 149 divided by 49. So careful lang sa fraction, no? Kasi pag nagkamali sa fraction, yun lang, no? So this gives us 490. Check my value. It is 490 over 5811 because I take the reciprocal. Remember, when you divide, you multiply by the reciprocal of the denominator. The denominator is 5811 over 490. Since we multiply, we take the reciprocal. What's the answer now? 1833 divided by 10, 43 multiplied to what fraction? 490 divided by 5811. So getting this value. You just check if my value is correct. 3290. Check my value, ha. Over 22,201. Is that correct, guys?
Yes,
Ha?
sir.
Yes, sir.
Yes po.
Ha?
Yes po.
Correct now? Divided by 149. I'm still checking. Divided by 10 minus 149 divided by 49. Okay, so that's right. So this is the answer. Or approximately, if you're asked of approximate value to, let's say, 5 decimal places, 0.14819. So this is the approximate value. If you're asked of the approximate value. Any question, guys? Guys, any question? Don't have. Let A and B be positive acute angles with AB, C positive real numbers. If cosine of angle A is equal to 2AB all over is A squared plus B squared, where A is greater than B and cotangent B is equal to 2 square root of AB over A minus B. Evaluate the and evaluate and simplify the expression a squared plus b squared sine A all over 2 square root of b tangent b. Okay? So this is what we are asked of to simplify. So again, A, B, C are all real numbers. Angle A and B are both positive acute angles. So it means we are dealing with two right triangle. I mean, we are dealing with right triangle. No? So, but it doesn't mean that A and B are in the same triangle. Okay? So what is guaranteed? They are what? They are both positive acute angles. So let's work on angle A first. So sine A, we're given sine A. So sine A is equal to what? Sorry, cosine A. We're given cosine A. So out of cosine A, we get what? We get we can get the value in terms of A and B, the value of opposite, no? So we have cosine A. Let's have here. What is cosine A? That is 2AB over A squared plus B squared. And this is defined as adjacent over hypotenuse. So from which we can get what? We can get the hypotenuse, I mean the opposite. Opposite is equal to square root of. Square root of what? So that is square of the hypotenuse, that is A squared plus B squared, quantity squared, minus square of the adjacent. We have 2AB quantity squared. Okay? So simplifying this, guys, so opposite, let me put it here, equals square root of. So we have to expand this binomial quantity squared. So that is A to the fourth plus 2A squared, B squared, and then plus B to the fourth minus 4A squared, B squared. So we can simplify the radicand by combining similar terms. So what are the similar terms? So we have A to the fourth plus, it will now become minus na, no? Minus 2A squared B squared, okay? We have minus 2A squared B squared, and then finally B to the fourth. Yan. Okay? Now, what do you notice in the radicand, guys? What's the radicand? This is a what? A perfect square trinomial, right? So that can be factored into A squared minus B squared, quantity squared. What's the square root again, guys? That is absolute value of A squared minus B squared. Now, do not conclude immediately that if you have, let's say, a perfect square containing variable inside the radical, like for instance, if I have a square root of A squared, do not conclude immediately that it is A, because it is possible that the value of A is negative. So you have to take the absolute value. But since A here is greater than B, so it means that A squared minus B squared is guaranteed to be never negative. So the absolute value of that is A squared minus B squared. Okay? Yan. Now next, what comes next? So let's have for cotangent B. For cotangent B, that is adjacent. So this is adjacent to A. This is hypotenuse to A. and this is opposite to A. What about cotangent B? Given we have 2 square root of AB all over A minus B. So this is defined as adjacent to what? Adjacent to angle B over opposite to angle B. Yan. So which means that our unknown is a hypotenuse. So the hypotenuse to angle B is equal to square root of, what's that hypotenuse? So that is square of what? Opposite. So A minus B, quantity squared, plus square of the adjacent. That is 2 square root of AB, quantity squared. Simplifying, so hypotenuse to side to angle B is equal to, that is equal to what? Square root of, so let's expand. So A squared minus 2 AB plus B squared, and then plus 4, and that is AB, no? So we can rearrange the terms in the radicand so that we'll have A squared plus 2AB, and then because negative 2AB and plus 4AB is what? 2AB, no? Then plus B squared. Yan, okay? This is equal to square root of A plus B quantity squared. So getting hypotenuse. What's now the hypotenuse? What's the hypotenuse? That is equal to absolute value of A plus B. But A and B are both positive. So guaranteed that it will never be negative. So the absolute value is A plus B. Okay? Now, since what again? Since this is what? Since our A is, the reason why, because our A and B are positive. Can we now evaluate the expression? So I think we're now ready to evaluate the expression. So we have A squared plus B squared multiplied to sine A, and that is all over 2 square root of B, then tangent of what? Tangent of B. Okay? And this is equal to, what is sine A? What is sine A? What is sine A, guys?
Sir.
What? A squared plus B squared times sine A. What is sine A? That
B
is
squared minus B squared
A squared, no? Is it A squared minus B squared?
over A plus B.
Over
A plus B.
A plus B. Ano A plus B? Di ba A squared plus B squared? Iho? Am I correct?
Sir, it says A plus B po sa taas.
Sa taas.
Hypotenuse.
Taas.
The first line sa right.
What is sine A?
Sir, hindi mo nalagay ng
Nang? How do we define sine A, guys? Opposite over? You can draw triangle
Continuous.
so that you will not be confused. You can draw triangle. This is A. And then another triangle. But the triangle are different from each other. No? I mean, we have, the B is not here because it is not said that they are complementary. So this is, A is, so this is 2AB over A squared plus B squared. And we have solved this, A squared minus B squared. Okay, that is opposite. For B, angle B, so that is cotangent, adjacent to square root of AB over opposite, So that is A minus B. So the hypotenuse, we solve that, A plus B. Okay? So what is sine A? Opposite over hypotenuse. Is that correct, guys? Guys?
Yes, sir.
Ayaw na nila sumagot. Nawala na si Miss President.
Sir, sumagot po sila. They said yes.
Ay, ano nga, tinatanong ko nga kung, is this correct now?
Yes po.
What about tangent B?
A minus B over 2 square root of AB.
Sorry?
A minus B over 2 square root of AB.
A
Minus
minus
B.
B over, all over,
2 square root of AB.
2 square root of AB. Okay? So let's simplify. So we can cancel this square root with this square root. That B only, ha? So we cancel 2. We cancel A squared plus B squared. A squared plus B squared. So getting what's now the remaining quantity? So we have A squared minus B squared all over A minus B over square root of what? Square root of A. Okay? And this is equal to A plus B, A minus B, the factored form, multiplied by the reciprocal of the denominator. Square root of A over A minus B. Okay? So this is now, this can now be further simplified into, yeah. So finally we have A plus B times the square root of A. Okay? So that's the value of that expression. Is that clear, guys? So, okay. So let's have number 6. Let's have number 6. Using the definitions of trigonometric functions of theta for the right triangle shown. So this is the right triangle. Prove by working on one side only that this expression on the left is equal to the expression on the right. And also, cosine theta all over 1 minus tangent theta is plus sine theta all over 1 minus cotangent theta is equal to sine theta plus cosine theta. Okay? So let's start with that. So this is something that is proving, no? So given 1 minus tangent square theta all over 1 plus tangent square theta plus 1 is equal to 2 cosine square theta. Let's work on the left side because it's better to work on the left side, making it the right side. So we're showing that we want to show that the left is equal to the right. Using this triangle, applying the definitions of trigonometric functions. So let's start. So this is equal to, what is tangent? Tangent is equal to, from this triangle, m over n relative to angle theta. That is m over n. But it is squared, so therefore quantity squared. Then in the denominator, 1 plus m over n quantity squared. So this is equal to, so let's simplify the numerator and denominator. 1 minus m squared over n squared all over 1 plus m squared over n squared. So to simplify this complex fraction, let's multiply both the numerator and denominator by n squared over n squared. Okay? So getting, so this is now equal to n squared times 1. So that is n squared minus n squared times m squared over n squared. That is m squared all over, in the denominator, that is n squared plus m squared. Okay? Now, the denominator can be written as what? Sorry, may plus 1 pa, no? I'm going to add later 1. So, this is just this expression. So, I need to have plus 1. Let me want to keep your ink annotations. Keep. So I'm going to erase this. No, okay. It's lagging. That's the problem of internet. So it is plus 1. Do you still see, guys?
Yes, sir.
Guys?
Yes po.
This is plus 1. And then I will move this here. So this is plus 1. What's the role of this one? Where is there 1 there? So this is, let me move this. There it goes. So then, okay. So we have plus 1. Okay now? So this is plus 1. So getting the LCD, we now get what? So that is equal to n squared minus m squared plus n squared plus m squared. Then all over, we have n squared plus m squared. Okay? And that is equal to n squared plus n squared is 2mn. 2mn. Sorry. So that is 2n squared all over. Yan. But the denominator, I can write that as r squared, guys. Now, why is it that I can write n squared plus m squared as r squared, guys? Anyone?
With the
Pythagorean
Pythagorean
theorem.
theorem.
Sorry?
With the Pythagorean theorem po.
Because of the Pythagorean, huh?
Opo.
That r squared is equal to m squared plus what? Plus n squared, which is equal to the denominator. So the denominator can what? Remember, our goal is to have it 2 cosine squared theta. So let us express this as a fraction. 2 of the form n over r, quantity squared. But what is this now, guys? What is n over r? That is cosine theta, right? But it is squared. So we have cosine theta quantity squared. Okay? That's it. So we have proven that the left is equal to the right. Okay? So using the definitions of trigonometric functions. Let's work on the second one. So let me put this on top. Copy. So I have an excess saving space. What about this? So prove that the left is equal to the right, meaning prove that cosine theta all over 1 minus tangent theta plus sine over 1 minus cotangent theta equals sine theta plus cosine theta. Okay? So again, so the triangle, because the triangle is not visible anymore, let me draw again the triangle. This is the triangle. Yan. This is R. This is theta. And this is M. This is N, if I'm not mistaken. M over N. Okay. So we now have, this is our reference, huh? So cosine theta. What is cosine theta, guys? Cosine theta is adjacent over hypotenuse. Then, N over R. What about tangent? Tangent is opposite over adjacent. And then plus sine theta is opposite over hypotenuse all over 1 minus cotangent is adjacent over opposite. Okay? So let's simplify. So we multiply the numerator by the reciprocal of what? The denominator, no? So we have n over r times the denominator is n minus m over n. So the reciprocal is n over n minus m. Then plus here we get m over r times what's the denominator? That is m minus n all over m. Reciprocal is m over m minus n. So now the denominator are actually not entirely different. They just differ in the sign. I can multiply both the numerator of this and the denominator by negative. So I get negative n squared over r multiplied by m minus n. So I multiply both the numerator and denominator by negative. So negative, then negative. So m minus n. So plus m squared all over r m minus n. So they now have the same denominator. So I can combine the numerator immediately. That is m squared minus n squared all over r, then m minus n. I can factor the numerator into m plus n and then m minus n. All over, we have r, then m minus n, from which I can cancel m minus n. So getting what? Just what? So just this. Okay? So almost time m plus n all over r. Okay? So that's it. So that's the sorry, not yet. Yeah, our proving. But I can split this into what? Into m over r plus what? N over r. But what is m over r? That is sine theta. But what is n over r? That is cosine theta. So we have shown that the left is really equal to the right. So actually, this means it is an identity. Okay? As long as theta will take value that will make all the expressions inside defined. Okay? So that's it. So we now have relationships among trigonometric functions. Yeah. So, co-function relationships. Let's say you're given this triangle ABC, where A and B are complementary angles of each other. No? So, from this right triangle, we can define the following. C is the hypotenuse, A opposite to angle A, and B is adjacent. We define sine A to be A over C, and that is equal to cosine B. And cosine B is equal to 90 minus A because they are complementary. So we say that sine A and cosine B are co-functions. Cosine A is equal to B over C. And if you read it from the triangle, sine B is also B over C. And sine B is equal to sine 90 minus A, and so on. So we say that cosine A is cofunction of sine B. Tangent A is cofunction of cotangent B. Cotangent A, the cofunction is tangent B. Secant A is the cofunction of cosecant B. Cosecant A, secant B. As long as the angles are complementary, sine, cosine are cofunctions. But be sure their angles are complementary. Tangent, cotangent. Secant, cosecant. Again, they are co-functions. And it's also called co-functions, complementary functions. And for the reciprocal relationships, we have what? The reciprocal relationships, we have the following. Tapusin na natin, ito na lang naman. So we have sine A is equal to A over C, but this A over C is equal to 1 over C over A. So we have 1 over cosecant A. Cosine A is equal to B over C. If you take secant A, that is B over C, take the reciprocal, that is B over C also, and so on. Sine A and cosecant A are cofunctions. Cosine and secant are cofunctions. Reciprocal functions. Sine A and cosecant A, reciprocal functions. Cosine and secant, they are reciprocal functions. Tangent and cotangent. But be sure their angles are equal. Unlike sa cofunctions, ang angle nila complementary angles. Sa reciprocal, same angle. Sa cofunctions, ang angles nila to be cofunctions, sine, cosine, dapat complementary angles. Okay? So that's it for today. So we'll continue next meeting. I do not know when the next meeting will be. May pasok ba ng Monday? Ayaw sumagot. Okay.
Wala po, sir.
Wala? Wow. So we will meet Tuesday next week.
Yeah.
Class on Monday, we need an extra day because we will be late. Okay? Next time, we will be discussing the continuation of this and yan. Evaluation lang naman. Yan. Tsaka yung examples na lang. Okay, you may go now. Guys. I-share ko na lang the video which is the one that is better. Kung sa section nyo or in other section. Kung alin na lang yung mas magandang video.
Bye, sir.
Tapos lang naman
Salamat po.
lecture. Okay.
Good day po, sir.
Salamat, sir. Bye po.
Okay.
Thank
Thank you,
you.
sir.
Nice
Thank you po.
All Souls Day and All Saints Day.
Thank you po, sir.
Hari nawa, huwag kayong dalawin ng mga mahal niyo sa buhay kasi baka hindi niyo sila madalaw. Baka mamaya sila ang dumalaw sa inyo.